It seems that everyone in the information security field is talking about zero trust architecture. Yes, much of that conversation is, oh, we have been zero trust for years. Oh, zero trust is so complicated. We are taking our time figuring out if it is right for us. Then, my first attempt at information security architecture began with a list of attributes: integrity, confidentiality, recoverability, accuracy that I gave to developers to ensure inclusion in the applications they were working on. From that approach, I moved on to chatting the access paths to data and ensuring that adequate security measures are applied on every path. So then we'll move about to there are a number of more substantive inhibitors that I would like to discuss here: insecure identity, over authorization, weak data management, incomplete knowledge of applications, everything and anything. First of all, uh, we talk about insecure identity. The essential promise of zero trust is that users must be verified every time they attempt to access information resources, not only at the point at which they sign in. Underline that is the assumption that an authenticated identifier can be associated with authorized resources. But what assurance is there that the users that entered the identified is actually the entity that it claims to be? The use of stolen credentials to perpetrate cyber attacks has been widely reported, although the incidence of such theft is not clear. We can say that if the validity of the identifier is suspect, verification of access right is unavailing. In that context, multi-factor authentication resolves that concern, but there are too many cases where stolen credentials have been used to dismiss the issue. Further, of authorization. Then we talk about this. Even if the identity of the user is valid, should that person have access to the requested resources? If the user has been authorized to do so, then the answer is yes. But the literature on zero trust architecture is largely silent on the process for granting, communicating, and enforcing access rights. Simply assuming that authorization has occurred, the process of authorization seen as external to the processes for protection. Despite the fact that protection hinders an authorization, this is an issue that, as I see it, must be addressed. For the when we talk about weak data management, limiting access to data and transaction is only meaningful if an organization knows what data it has, what it looks like, and where it is. In other words, is able to manage its data. Some enterprises have effective data management functions, but in my experience, that is limited to large companies and government agencies. Evidently, managed data is a luxury that small organizations cannot afford. Zero trust architecture can protect against misuse of data, but it cannot protect data that no one is aware of. This is particularly a conundrum with regard to personally identifiable information. Fields such as name, address, email address, telephone number are often extracted, replicated, transmitted, and copied from their primary databases for specialized users. If we talk about incomplete knowledge of applications, just as many organizations are unaware of their data, many also do not know what application software they have. Of course, they know the applications they use most of the time, but do they know the ones used by only a limited number of users, only at certain times? Prior versions, upgrades of many application systems may have been retained for many years because you never know. There are those acquired by business departments unknown to the information security function, and there is the application that only we knew how to maintain and how what are the outdated softwares. From all the foregoing, we can assume that we will see inhibitors too great to overcome. But that is not the case at all with regard to zero trust architecture. Note that of the four inhibitors I address, two are not uniquely zero trust problems. Those are insecure identities and over authorization. We have been facing them for as long as we have been involved in information security, and they have not stopped us from proceeding. The second two, weak data management and incomplete knowledge of applications, are shocks that information technology is here to. If we had waited to solve these before we secured information resources, we would have no security at all. Delay in the implementation of a security architecture that is clearly the best that has been designed so far is to say that if one cannot have everything one wants, then having nothing is preferable. This attitude, I believe, is beyond childish, it is self defeating. I say that because in my career I have seen many threats to the security of information resources mitigated but not overcoming completely. Computer viruses have been a known problem for quite a while. Antivirus software has not solved it, but we have continued computing. Passwords have long been known to be weak protection, but we still use them, with multi-factor authentication increasing their effectiveness. So personally, I see 5 basic concepts in zero trust architecture. These are: ensure all resources are accessed securely regardless of location, adopt a least privilege strategy and strictly enforce access controls, inspect and log all traffic, permit no lateral movement without validation, segment networks in alignment with access requirements. So I would like to wind up my this video. Hope you will get more understanding about zero trust architecture. Thank you.